All right, so this video is going to cover vertical motion word problems. I've already shared this with you, but just in case you want to write it down, these are the kind of key phrases that we'll see when we're solving these types of word problems and what we're asking for when we see them. So let's get started. A penny is thrown up into the air from the top of a building. Its path can be modeled by the equation where t is the time in seconds since the penny was thrown and h is its height in feet. So how high off the ground is the penny before it's thrown? So to start, it's going to start at the y-intercept. So its starting height is the y-intercept, which is always the c value. So it's going to start 35 feet off of the ground. I want to keep a sketch of what's going on in this problem, just to help me visualize. So we're going to have the y-axis be the height of the penny, and the x-axis is going to be the time since it's been thrown. So at time 0, the penny is starting pretty high off the ground, 35 feet. We know that it's going to be thrown up into the air, and then it's going to come back down and hit the ground. So the key points on this parabola are its starting height, its maximum height, and then when it hits the ground. So as we go along, we will fill in those key points. So at what time does the penny reach its maximum height? So as we know, the maximum of a parabola is the vertex. And when they ask for the time, they're really asking for the x-coordinate of the vertex, which we can calculate by doing negative b over 2a. That formula gives us the x-coordinate. So b is 10, a is negative 16. So we're going to do opposite of b over 2 times a. So that's negative 10 over negative 32, which we're going to round to the nearest hundredth, is going to be 0.31. So it's going to take 0.31 seconds to get to the maximum height. So if I go back to my graph, this highest point is 0.31 seconds after the penny is thrown. And then they want to know what is the maximum height. So we know max, again, is vertex, and the height is the y-coordinate of the vertex. So to find that, we're going to replace t, the time, with the time it takes to get to the maximum height, which is what we just found in the last problem. And so let's see what our calculator gives us when we do that. So negative 16 times 0.31 squared plus 10 times 0.31 plus, it started off at 35 feet. So if we round to the nearest hundredth, that's going to give us 36.56. So the maximum height is 36.56 feet. So if we look back at our diagram, we knew the time it was going to take to get to the maximum height, and we know the maximum height is 36.56. So it's actually not much higher than its initial height. I'm actually going to redraw this graph for our next video just to make it a little bit more accurate, even though it's just a sketch.